How's everyone doing on the homework so far with lesson one? Good. Making some progress. Let me turn this one off. All right. So just to kind of, again, I'll record each session, and then where I'm posting them is in the learning objectives part. You'll see you get the slide deck. We did 2 recordings to get through. We'll see what we get today. And we have 2 days for each lesson. So we have hopefully an introductory day. Hopefully we'll get through most of it, if not all of it, and maybe a little time to start the homework. And then, what's today? Today's Wednesday. Monday would be completely tutored math. So that's where you can come in, ask any questions you want, work through things. So today is our scheduled time to move on to lesson 2. And I'm still going with, I think there is, let's see, I guess I could just scroll to the bottom. I thought there was 14 lessons. Yeah, so we have 14 lessons. We have 14 weeks. We'll squeeze everything in. It'll all fit just fine. And I'm starting to get the PowerPoints. I'm narrowing down to basically just what we use, because again, they're taken from the textbooks, so they're not outlined, so they've got some decent examples in there. We'll use those to kind of learn the material. And again, if you pull up I'm taking out some of the really verbiage parts of things so that you can go to the textbook for, and we'll see that we'll get more explanation as we go through. Okay. So lesson 2, we're going to start talking about rates of change. Maybe. Oh, there we go. And that just came on. Okay, we'll see how long it stays on. Oh, I know. I should just keep quiet. Okay, we'll whisper and get it. Okay. Anyway, so rates of change. So what's a rate of change? What is change? Just in general. No mathematical definition. If you're going to change something, what are you going to do?
Something that doesn't remain constant over a period of time.
Okay. Something gets different, right? Somehow it's different, or at least, I guess we could also consider there could be no change, right? Things stay the same, and that's sort of a change. So, and especially mathematically, we talk about rates of change. It could have a 0 rate of change, which means something's not changing, okay? Mathematically, we're going to talk about the difference, because we think in 2 dimensions of x and y on a graph. So we're thinking, how does the x change and how does the y change? And how do they change sort of together? We can examine that mathematically with a ratio. So the change in the vertical divided by the change of the horizontal is something that will tell us where our new position will be. And so that's really what we're going to talk about rates of change is there's 2 things that are changing, but when we're going to calculate a way to think of it as one thing. And that's going to be thinking it sort of as an angle. Both x and y are changing, but what's the end result? And that's what we call also slope. So we'll refer to rates of change. We'll refer to slopes. It's actually what we're talking about is average rate of change. So between 2 points, not really. When you get into calculus, you'll talk about instantaneous rate of change at a point, but we're talking average rate of change over 2 points. Okay, so that's all it is change. If I give you 2 numbers, let's say 5 and 7, how would you calculate change? The numbers between. How do we get how many numbers are between 5 and 7? Subtraction. Very good. 5 from 7 or 7 from 5. So depending upon which way we're going, we could either think of it as a change of +2 or a change of -2, depending upon which way we're going. Excellent. So subtraction mathematically gives us change. Okay, and that division is what we're going to look at. That gives us a way to take in 2 different types of changes, a vertical change and a horizontal change, and we've got a number, but we've got to visualize what that number really means. Okay. So that's our introduction, and we'll kind of go. Let's see if I